Hi, thanks for joining me. This presentation is going to cover the highlights of the North Coast in-stream flow policy, also known as the policy for maintaining in-stream flows in Northern California coastal streams. The goal of this policy is to maintain in-stream flows for the protection of fishery resources while minimizing water supply impacts on other beneficial uses of water. The focus is really on native fish populations, in particular anadromous salmonids, which includes species like coho salmon and steelhead trout. The geographic scope of the policy covers a big stretch of Northern California, so it includes all of Marin and Sonoma counties, as well as parts of Napa, Mendocino, and Humboldt. And within those counties, the coastal streams from the Mattole River up in the north in the middle of Humboldt County, all the way down to San Francisco, as well as the coastal streams entering into San Pablo Bay. The policy was first adopted way back in 2010, subsequently set aside in 2012 as a result of some legal challenges to the policy, readopted in October of 2013, and it's remained effective since being uh, in place in February 2014. So how this policy is implemented is it establishes guidelines for evaluating the potential impacts of water diversion projects on stream hydrology and biological resources. And it does this by providing protective measures regarding the season of diversion, minimum bypass flows, and maximum cumulative diversion amounts. So this really controls the timing, the rate, and the total volume of water that can be diverted from for new water rights that are issued under the policy. And the principle is really to ensure that new water appropriations and changes to existing licenses and permits will not affect the in-stream flows needed for spawning, migration, and rearing, or the flows needed to maintain natural flow variability. And new water appropriations also won't impact those existing licenses and permits. So it has two objectives. One, really to ensure that any new water rights that are issued don't impact the availability of water for senior water rights holders, and also that new water rights that are issued don't impact the habitat needs of species that rely on that water as well. The process is wrapped up in what's called a water availability analysis. And within this water availability analysis, there's two steps. So the first step is the creation of a water supply report. So what this does is take a look at the unappropriated water supply at the project point of diversion and also at downstream senior water rights, moving downstream from that project point of diversion. This first report is submitted to the State Water Board for review. Following on from the submission of that report, what happens next is there's a determination made for the upper limit of anadromy, the stream class for streams downstream of the point of diversion, and the selection of points of interest along that downstream flow path. The upper limit of anadromy describes essentially how far upstream anadromous fish travel. And the stream class really classifies the streams into different types. And those stream classifications have implications for some of the subsequent analysis that happens. Now, these points of interest that get selected, we'll talk about a little bit more as we move through this presentation, but they're essentially locations where there's further analysis required in the later stages of conducting a water availability analysis. Now, the state board, in consultation with California Department of Fish and Wildlife, determines the upstream limit of anadromy. the stream classes, and selects points of interest for subsequent analysis if and only if the water supply report demonstrates at a gross scale that there's remaining available water at that location. Once the proponent receives back the ULA designation, the stream class determination, as well as the points of interest to be used, those points of interest um, are translated uh, and used to perform cumulative diversion analyses. And that's the second big part of producing a water availability analysis. Within that cumulative diversion analysis, there's a daily flow study, which is conducted at those locations, those points of interest selected by the water board. And that daily flow study determines impacts on February median flow, determines impacts on the natural flow variability. And within that daily flow study, a proponent is able to use either regional criteria, which is based on characteristics of the timing and availability of flow as represented in the streamflow record, or they also have the ability to use regional criteria or to use site-specific studies, which are uh, typically reports that would be produced by a biologist or some other qualified professional, which actually specifies the in-stream flows required at that location for specific habitat needs. Now, diving in to a little bit more detail of how this water supply report and cumulative diversion analysis works, the next series of slides is going to walk you through step by step how to actually produce these reports and analyses within the North Coast Water Availability Tool. So as you recall, step one is to produce the water supply report. The first part of that is to locate your project point of diversion. So you do that within the interface by essentially dropping a marker on the map. The that icon that we see in the middle of the screen that looks like a road with a fork in it, that represents our proposed point of diversion. The second step is to select the stream reach that's associated with that proposed point of diversion. And you can do that within the map as well too, simply by choosing, at the top right of the map there, we see that choose POD is selected. So once we've indicated our point of diversion, we would then hit the choose stream reach button and select the water body or the stream reach that's associated with that proposed point of diversion. The second step in the preparation of the water supply report is to provide information on the actual diversion itself. So this includes the start and end date for your proposed diversion period. It also includes the total volume of diversion and the maximum rate of diversion. And if you're proposing a project that uses a site-specific study to determine a minimum bypass flow, the third step on this screen would be to enter that value in at the bottom. So it's not required to do that if you're evaluating a project within the policy season that uses the regional criteria. But if you're trying to evaluate a project that uses a site-specific study, or trying to evaluate a project that proposes diversion that extends outside of the policy season, then you'll need to populate that information here. Once you've set up the information about your project, we then need to determine which stream gauge will be used to estimate the supply of water at your project point of diversion location. And that's done by selecting an existing streamflow gauge, which has been measuring um, uh, streamflow in a stream or a river within the project area, and using that as a proxy for estimating streamflow at your proposed project. So within the water availability tool, there's a set of algorithms that will um, suggest or recommend specific candidates to be used to estimate the stream flow. Uh, these candidates are recommended based on their similarity in terms of watershed characteristics between the watershed associated with the stream flow gauge and the watershed associated with your project point of diversion. So what this does is it compares those two watersheds on the basis of things like the size of the watershed, the geographic proximity, whether the watersheds are hydrologically connected in some way. So, for example, if there's a stream gauge downstream on the system where your project point of diversion is, it also takes into account physical characteristics of the watershed. So things like the amount of annual precipitation, the distribution of precipitation over the course of the year, the geology, the topography, a number of additional characteristics. Um, you're not required to select one of these candidate gauges. You're able to choose any gauge of your preference that's available within the tool. There's about 60 gauges that are included, and that includes gauges that are both within the project area and as well as a few of them which are outside of the project area, but were determined to have sufficiently long flow records and a sufficiently high quality of data that would be suitable for extrapolating flows within the project area as well. So once we have our supply side information sorted out, we need to review and uh, make corrections as needed to information available on senior diverters within the project watershed. So this data is already assembled by the tool. The data is collected from a few different sources, combined, and then is provided for you to download and review on your own computer. So the things that need to be reviewed and verified are things like face value amounts for water rights, storage amounts, seasons of storage or seasons of diversion. Minimum bypass flows is a critical factor that needs to be, um, in most cases, actually added into this table because it's not um, available from the digital downloads from the state. So I want to emphasize that this is a really critically important part of the process in performing a water availability analysis, is to ensure that the representation of senior water rights is accurate. Um, in the process of determining the accuracy and correcting any mistakes, you may need to go and review actual scanned copies of paper rights associated with the senior water rights in your watershed to ensure that all of the data is available and represented in this senior diverters table that you download. Once you've downloaded, reviewed, made any corrections as necessary, that table is then re-uploaded back into the tool, and then you can move on from that step. And the next step in the water supply report is really just to get the results. So there's a set of criteria which is uh, described in the policy itself for information, maps, tabular summaries, raw data, so on and so forth, that's required to be submitted along with the water supply report itself to the state board for their review. So all of those requisite supporting files are provided in an output package that you can download from the tool. What the tool doesn't do is write your water supply report for you. Um, so there is some work required still, to prepare an application package, to write a narrative describing the objectives of your project, um, other relevant factors. Um, all of that information has to be consolidated uh, alongside the technical information that gets provided in the water supply report output package. As we can see in the screenshot on the left side there, there's a bunch of files. So there's text files, there's image files, as well as tables of data. There's also uh, documentation on the methods that were used by the tool to produce these outputs. So that includes information on how the calculations were made, how watersheds were recommended for selection when estimating the water supply, um, uh, and so on. So with that information, once we've taken that technical information, combined it with our narrative summary of what our project is setting out to do, that information is then submitted to the water board. So the water board at that point will review the project. If there appears to be unappropriated water available, then the upper limit of anadromy in the project watershed will be determined. Stream classes along the downstream flow path will be defined, and the locations of interest for the cumulative diversion analysis will be specified. And those locations are typically either at senior water rights, which are downstream of your proposed project, or at significant confluences where major tributaries sort of combine along the downstream flow path. There is, of course, other potential locations that could be um, selected for or selected as points of interest. That's just an example of types of what they could be. So moving into part two, the cumulative diversion analysis. This won't be something that you do on the same day as preparing the water supply report. Once the water supply report is prepared and submitted to the state board, there's likely going to be a period of weeks or months before the information comes back to you, and then you can revisit your project within the tool and move on to the cumulative diversion analysis step. One of the things that I didn't mention at the start is that prior to doing any of this work within the tool, you have to sign up and register for an account. You can use either your Google credentials if you have those to log in, or you can create an account just within the tool. But one of the reasons that we have to do that is so that the information that you prepare within the water supply report is available to you within the tool when you come back and want to move on to part two in the preparation of the cumulative diversion analysis. So if you recall the information that we received back from the water board, one of those pieces of information includes the points of interest. Um, so the first step in the creation or in the production of the cumulative diversion analysis is recording those points of interest within the tool itself. So we can provide names associated with those points of interest. We can also define the stream class associated with those points of interest. We can also determine whether these points of interest are where they're at in relation to the upstream limit of anadromy. So, either below that limit or at or above. One of the tricky parts with doing this sort of automated analysis is how to determine um, who's upstream of who. So when water rights are closely clustered together, there may be some lack of precision in how those rights were uh, located within the data system. One of the steps in the creation of these points of interest is actually defining where in that hierarchy each point of interest lives. So when you create these points of interest, one of the steps that you're required to do is tell the tool what the next upstream diverter is from your point of interest. Now, once all of those points of interest are recorded within the tool, you can move on to the next step, which is the determination of what type of criteria that you'd like to use. So at this point, you can choose to use only the regional criteria. So this would be the case, if you haven't done a site-specific study, if you don't have any specific information on minimum bypass flows or uh, other related information at these points of interest. If you do select the regional criteria, you still are able to modify those um, at the next step. But if you choose the site-specific or alternative criteria only, you have to provide 100% of the information for the subsequent steps. And that's so one of the optional steps in the production of the cumulative diversion analysis is to unimpair the gauge data. So streamflow records that are available within the tool, in most cases, will have some existing impact in the observed streamflow that they're recording. So it's highly likely that there is diverters upstream of those gauges who are withdrawing water, who are diverting water, and those diversions would be reflected on the gauged record. So an optional step in the production of the cumulative diversion analysis is actually to review the senior water rights in the gauged watershed so that that water can actually be added back into the flow record. And this is optional because by this point, you've likely uh, already gone through and reviewed the senior water diverters for your project watershed, which is a required step. And depending on how many senior diverters are within the gauged watershed, you may or may not want to devote that same, or, in the case of there being a significantly large amount of diverters in the gauged watershed, a much greater time investment associated with performing that QA on the senior diverters information. So you can elect to use observed streamflow data only here. What that would do overall is sort of um, reduce the amount of water available for your project. So it is from an environmental protection perspective, it's not going to make your project look better. It's going to be a more conservative analysis of your project. So depending on what you elected at that last question around whether you wanted to unimpair the streamflow record, once you get past that step, the daily flow study can be conducted. So the results of this daily flow study are provided within the interface for the tool itself. So you can see how your project did in relation um, to the management targets around the preservation of flow. And then you're essentially done at this point. So you're able to export the results of your cumulative diversion analysis into an output package as well. Similar to the water supply report, there's a very thorough description of the required documentation associated with the analysis. All of that data and information is provided, as well as metadata describing the methods used, the data sources, how everything was done. And similar again to the water supply report, the tool is not going to write your report for you, so you need to take the technical analysis required under the policy. combine that with your narrative and package it up into something that you'll then submit to the water board for their review. So that gets us through the sort of nuts and bolts of the policy itself and how you can step through the required calculations as described by the policy. We'll just talk quickly about some of the data that's available within the tool. So for the senior water rights information, this data is sourced and combined from uh, two data sets in the California Open Data Portal, as well as an additional data source which augments that information with data on riparian water rights. The linkage between these two data sets is established through the application number and a water right ID column. Streamflow data, which is again critically important. That data within the tool is sourced from USGS gauges, as I mentioned earlier, within or nearby the policy area. Only full water years are used for the analysis, and gauges that have less than 10 complete water years in their records are excluded and are not available for use in the analysis. The hydrography data, which represents the streams, the connectivity between streams, as well as the watersheds associated with those streams, all of that data is sourced from the National Hydrography Dataset, or the NHD plus HR dataset. The streams and rivers as provided by the NHD are used as is. The watershed boundaries associated with those streams have been aggregated to represent complete upstream watersheds associated with each stream reach. And in the process of curating the data to provide those upstream watersheds, missing connectivity within the source data set was corrected where it was identified. There's a number of ancillary data sources which are incorporated into the tool. These aren't things that are used critically for the calculations, but are used to adjust and prepare data that is used for the calculations. One of the most significant data sets is the PRISM climate data. That data is used for recommending gauges. It's also used for adjusting streamflow records associated with the project based on the comparative difference between precipitation within the project watershed and precipitation within the gauge watershed. Elevation data from the USGS 3D elevation program is used to both generate the PRISM estimates of annual and monthly precipitation. It's also used in the gauge recommendation engine to characterize the topography of the watersheds. Finally, land cover and vegetation data from CAL FIRE is used also in that gauge recommendation engine, as is generalized with lithology data from the USGS. So there's some gaps which you might have picked up on so far in this presentation, but I'll just highlight a couple of these before we wrap up. One of the gaps is around senior water rights. So the process of QA and performing the QA and augmenting the data that's available for these senior water rights. There's currently a gap now between what's required for execution of the policy and what's available in that digital data. The State Water Board is working towards a release of CalWaters in the second half of 2025, which is intended to replace the existing eRIMS system where the data on senior water rights is currently acquired from. Some of these gaps will hopefully be closed in the coming years as CalWaters goes into production, but until that time, individual review of each record associated with water rights in your project watershed will most likely still be required until such time that the entire paper archives have been converted into a digital format, and all of that data is represented within those digital files that are available. The other gap is around streamflow records. So the terrain and the topography, the climate of the project area can be very diverse. These are coastal watersheds, and with only about 60 gauge records available for use, if, especially for some projects which are on smaller creeks, it might be difficult to find suitable proximal gauges for analysis. And although there is a requirement to have 10 full water years of data for a gauge to be suitable for use in the analysis, there are still significant gaps in the body of knowledge around streamflow characteristics, which would benefit from further investment in the collection of hydrometric data, especially for smaller streams, especially for streams which are not geographically close to an existing streamflow gauge. Before we wrap up here, I just wanted to highlight one other important aspect of the North Coast Water Allocation Tool. The data that's collected and analyzed and distributed through the tool can be used for a variety of purposes beyond the production of a water availability analysis. The creation of a estimated streamflow record um, can be achieved within this tool for any location within the North Coast region. That means that even if you don't need to produce a water availability analysis, if you are looking for an estimate of streamflow at an ungauged location, you can produce that within the tool. Similarly, if you need to acquire water rights for a watershed of interest um, to perform some other kind of analysis that isn't a water availability analysis, you can also acquire that data through the tool and have it already be linked up in a manner that provides as fulsome a description of the water rights as possible. I just wanted to highlight those things as we wrapped up because I think the significance of what can be produced from the tool um, is significant, but there are a whole bunch of ways that the inputs to the analysis can also be used for multiple other purposes. And with that, I'll wrap up. Thanks for your attention. And if you have any questions, please reach out. We'd be happy to chat about any issues you have, any thoughts or ideas that you have with the tool. Thanks very much.